Hello everyone, and a warm welcome to you. In this tutorial, we will be discussing how to process mosquito larval samples. Mosquito larvae are collected for different purposes. Most of the time, you simply want to know what species of mosquitoes are breeding at particular sites. So for most field collections, you want to identify the larvae. You can do this in two ways. Firstly, you can rear the larvae through to the adult stage and then identify the adults, which many entomologists prefer to do. Or, secondly, you can preserve the larvae and do direct microscopic identifications of the larvae. If you decide to rear the larvae to the adult stage so you can use the adults for identification, you will need to keep the larvae in containers until the adult mosquitoes emerge. Remember, always keep larval specimens collected from one sampling site separate from larvae collected from another site, so you can associate the mosquito species with a particular breeding habitat. For example, does this species prefer sunlit, clear water, or does it prefer heavily vegetated water, and so on. So each set of larvae collected from a particular breeding site must be kept in their own container and their own specific code that links them with collection data in your data spreadsheet. Most field collections from specific habitats or breeding pools yield low numbers of larvae. And to save space, it is easiest to keep the larvae in small containers with water taken from that particular habitat site. Transfer the larvae you have collected into the cup. Make sure to remove all non-anopheline larvae using a pipette. Many species of mosquitoes have predatory larvae and they will kill the Anopheles larvae, so take them out. Now cover the container with netting. The netting must have a slit in it so you can insert an aspirator when an adult mosquito emerges. Block the slit with cotton wool so adults cannot escape. Always label the cup, even if it is just a code to link it with the full collection data in your spreadsheet. Keep the cup with larvae in a warm but shaded site away from direct sunlight. Ideally inside the insectary at about 25 degrees centigrade. Feed the larvae with powdered fish flakes or other prepared larval food as explained in the tutorial on insectary management. Because the container is small, you need only put in a small amount of food once a day. When an adult mosquito emerges, you can remove it with an aspirator. Transfer it to another cup and keep it in there for 24 hours for the cuticle and genitalia to stabilize. Then place the container in a freezer until the adult mosquitoes are dead, after which you can either pin them for microscopic identification or place them in a small tube with silica gel beads for PCR analysis. If you have many larvae that you collected from one pool, more than about 20, then split the larvae into several cups, between 8 and 5 larvae per cup. If you decide not to rear the larvae through to adult stage, but preserve them for microscopic or PCR identification, then please proceed as follows. Using a pipette, transfer each larva into a bottle with 80% ethanol. Try to transfer as little water as possible as it dilutes the ethanol. Leave the specimens in the ethanol for an hour, then transfer the specimens to another bottle with fresh 80% ethanol. Then transfer once again to fresh 80% ethanol. Now insert a label with a code and collection data on a small paper label inside the ethanol, using a pencil for writing or India ink which does not dissipate in the ethanol. The data label should ideally have the locality of collection, date of collection, name of collector, and the code of the sample which links it to the data spreadsheet. If you intend to use the larvae for PCR purposes, then you should use 95% or absolute ethanol. If you do not intend to do the PCR assays within a few days, then store the tubes in a freezer at minus 80 degrees centigrade. Here's a manual that provides excellent guidelines for processing mosquito samples, including larvae.